Hello and welcome back from the break. My name is Nina Wambugu and I am the coach of the Gemeinde Kirchheim team, which is made up of our customers, Tobias Schock and René Fassbender, our project lead, Mariana Avitzum, and 6 lovely developers, Florian, Natalie, Pandarit, Berzan, Patrick, and David. So let's get things moving by talking about traffic.
So while the population of Germany from 2000 to 2018 increased by roughly 700,000, the amount of cars owned increased by about 4 million. Munich's population increased by roughly 300,000 in the same time period. And Kirchheim's population since 1970 has increased 7-fold. With more and more people commuting to and from Kirchheim, and especially to and from the industrial area to the east of Kirchheim, the traffic situation gets worse and worse, and traffic planning as a solution to this problem becomes more complex. With the help of our partners at Gemeinde Kirchheim, we have received a lot of data sources to tackle this problem. One such data source is the HERE API, which provides us with a traffic context consisting of a free flow speed, which is average speed on a road without congestion, congested speed, and congestion status, with which we can calculate an expected quality of travel for each road. We also have incident data available, which can be road closures or accidents, detailed by geolocation, timestamp, length of the incident, and criticality. We also have sensors installed at key locations in Kirchheim to provide further details on average speed and cars per minute. These key locations are the junctions to the Autobahn and the streets leading to the industrial area to the east. We even have air quality data available in real time, which is measured in ozone, particulate matter, and nitrogen dioxide. With the help of all of this data and additional statistics from the Gemeinde Kirchheim, we were able to calibrate a simulation that accurately depicts real life and helps plan ahead. We are even able to compare different simulation scenarios, like a morning and a noon scenario, with a heat map visualization in this case. With the help of all of these tools, traffic planning now will become better and easier for Kirchheim. Now you will see all of this in a live demo by my teammates.
This is Frank Cleverman. Frank just got a new job in Kirchheim, and today it's his first day. He now checks the current traffic situation in Kirchheim with his new mobile app called Smart Time Squared. When he opens the app, he can directly see the visualized current traffic. Red roads mean high traffic, and green roads mean low traffic. On the bottom of the screen, the app visualizes him the overall traffic situation by a bar that is more green for good traffic situation or more red for bad traffic situation. In details, he can inspect the average speed of the cars passing the 4 measuring stations by clicking on them. Frank can also swipe up from the bottom to get additional information. There, the app shows current warnings such as construction or a traffic accident. But that's not all. Smart Time Squared also offers Frank some useful recommendations, like avoiding a certain road on his way to work. Frank wants to know how usually the traffic situation around Kirchheim looks like. Therefore, he can also select 4 more days. By that, he, for example, gets to know for which days of the week he has to calculate a little more time for his way to work, and on which day traffic situation is normally better. But the Smart Time Squared app is not only a useful tool for residents or employees of Kirchheim. There is also a web application that provides some great features that traffic planners can use to analyze, simulate, and thus improve the traffic in Kirchheim. Just as with a mobile app, our traffic planner, John Smartboy, can have a look at the current traffic situation in Kirchheim and get warnings if a new construction is built up or an accident happened. Moreover, air quality sensors in the municipality allow him to check the air quality index, which is shown in the app. He does not only want to see the real-time traffic, but also wants to simulate some scenarios to get even more insights. He, therefore, starts a new traffic simulation for the morning rush hour. In order to see where cars come from and where they go in detail, he selected for the simulation to show the cars in different colors depending on their origin. He can also choose to color them based on destination. The simulation now pictures the vehicles in pink if they're coming from Heimstetten, in orange if they're coming from Kirchheim, and in blue if they are coming from a different location. All that helps John to understand the reasons for congestion, to create helpful new measures, and thus improve the whole traffic situation. The simulation data is also automatically sent to the web application. On the web app, there are several ways to visualize some of the most important data from the simulations. John can, for example, take a look at the different average speeds at the Bremiker boxes. He can also display a heat map that shows him the traffic volume for that particular scenario. The traffic volume basically shows where the most amount of cars ran through during the simulation. It may take a few seconds to load because of a large amount of data that is being parsed from the simulation. Lastly, John can also open up the statistics view where some of the most important data is displayed in forms of box plots. For example, the overall density, occupancy, speed, and the travel time. But the most powerful feature of the application is the comparison view. Here, John can compare the data of the different scenarios he has created and export it side by side. He can compare, for instance, the data of the morning rush hour scenario to the data of the noon scenario. This can give him valuable hints about the right measures to increase the traffic flow and therefore improve the traffic situations as well. So, as we can see, both the mobile app and the web app help people to deal with the traffic in and around Kirchheim.
So now that we've seen our applications in action, I would quickly like to walk you through the main challenges that we faced during development. Firstly, our system was very complex. We had a lot of different components, a lot of different data sources, and various types of stakeholders. So we had to come up with a very universal traffic model that was also extensible to new sensors. Unfortunately, the quality of the data wasn't as high as we expected. For example, the Bremiker sensors unfortunately perform less reliable when there is a high amount of traffic. Therefore, it was hard to derive useful recommendations, and we had to adjust our initial vision to that. The work with the simulation software was harder than anticipated, just because it has a very hard to navigate documentation, and there is a small community working with it. So when there arose an issue, it took a long time to solve them. However, we were able to implement a lot of features that are helpful. For example, the traffic planner can now, on the web application, see and compare traffic, see traffic warning and compare statistics. On the iOS application, we provide commuters with useful information so they can optimize their travel time and plan their routes according to traffic. And the simulation is now calibrated according to the sensor data and statistics provided by Kirchheim. So that is actually a useful tool for traffic planners to visualize the routes of possible congestion problems. Lastly, as with any project, of course, there's improvements that could be made, and I'm very happy to share that a lot is happening in the Kirchheim traffic project. Currently, Kirchheim is working on procuring more and new sensors to improve the quality of the data. And to evaluate the effects of new road construction, there is work in progress to extend the simulation with editable maps. With that, I have come to the end of our presentation, and we would really like to thank our customers for their support and letting us take part in this interesting project. And I would like to now hand over to Tobias Schock for some final feedback.
Yeah, I would like to thank you on behalf of the community Kirchheim for doing a really great job. I think you've done something, you really helped us out here. You've really contributed to a better planning in the future. Really, thanks a lot for doing such an amazing job. This is only just the beginning. We already agreed on doing another iPraktikum next semester to further develop this tool on further applications, like the environment stuff you were talking about, and also like the city planning, like also constructing buildings and stuff. No? So you really helped us out, also understand this new world for us. And yeah, I'm quite happy to also present the results on the 19th of September to the county of Munich, to all the other communities, and brag about it. Thanks a lot. Huh?